Hello, this is my Lab 2 Lines of Charge lab video. Um, so to get into some of the fundamental physics principles involved, um, so this lab deals with line charges, which is when we're trying to find like the electric field along infinitely thin line. And so we treat it as a series of infinitely small point charges. And so with this, to find the formula, we want to describe delta Q in terms of charge density of the rod. So you can see here how we say delta Q equals Q over L times delta Y. And then from there, we can substitute into the point charge formula and then derive what the electric field is of a rod. And so here you can see the magnitude is equal to this formula here when you're perpendicular from the center, and when you're far away from or if you're very up close to the rod, actually it behaves like this. If you're far away from the rod, it behaves like a point charge. But you can see the derivation right here. So some experiment questions before we start. Um, the length of a piece of the tape was about 8.5 inches, or about that much meters, and then the mass was 2 times 10 to the negative 4 kilograms. And the distance between the two tapes was 0.04 meters, about 2 inches. And the magnitude of gravitational force I calculated by doing mass times gravitational constant, and this is what I got. And the magnitude of the electric force should be about the same. So that's what I got. So with my glow script model, the white arrow is electric force, the yellow arrow is a gravitational force, and then the green arrows are the electric force on the tape due to the bottom tape for each piece. And so you can see how there's two pieces of tape floating, and it's supposed to be like even, so that way they're suspended in the air. But we broke up the tape into all these small little charges, and so to calculate the white arrow, we ended up adding up all the green arrows. But you can see what the electric force is and what the gravitational force is, how we calculated it in the computational model. So this is what my code looks like. So we have like some constants defined, and then this is the mass of the tape that I talked about earlier. And from lab 1, this is the charge that I estimated on one tape. And then this is my equation for calculating an electric field, and it's just going to return E. Um, and then this is a function that creates like a line charge and splits it up. And so it's like it allows us to approximate it with the um, point charge formula. And here you can see how we created top tape and a bottom tape. And then what these for loops are doing is they're calculating the electric force on the top tape due to the bottom tape. And how they're going to do that is add up each little piece of the charge. And then here in the code, you can see the two arrows, the white and the yellow one, and then the green one is up here. And so it's making one for each. So some of the questions were, what were the magnitude of the charge on one piece of tape as calculated in your computational model? And I calculated it to be 2.57 times 10 to the negative 4 newtons. And so with this lab, some assumptions I had were that we're ignoring air resistance as well as the interactions between the pieces of charge. And we're also assuming an even charge distribution throughout. We're not assuming, however, that it's acting like a point charge because we're using this rod approximation, and specifically not saying modeling it as a point charge. And then also, if we modeled it like a point charge, we would got a different value. Like in lab 1, we got this value, but in lab 2, we got a value that was a little bit different. And these are different because um, there's different equations for a point charge and a line charge, just because like the distribution of charge is going to be different, and the little like charges are going to interact with each other in a different way. So they're going to have different equations for finding electric field. And the line charge is more likely to be close to the real value because it's most consistent with the real shape of tape. And that concludes my lab video report. So hope everything made sense.